in Simcenter 12. We'll focus on three main areas: meshing, post-processing, and continuous improvements. We'll begin with meshing. In meshing, we have many new capabilities introduced in Simcenter 12. Because we will only be focusing on a few of these new capabilities, if you'd like to review all of them, you can do so at our website listed in the bottom right under the What's New section. With 3D swept meshing, we have a new capability to select multiple source faces when selecting until target from source to target faces. The only restriction is that the number of source faces and number of target faces need to be equal. And this reduces the amount of pre-processing that's needed to the geometry in terms of dividing it up or partitioning it or splitting the body in order to get sweepable bodies. We also have new capabilities with merge edge to be able to box select multiple vertices at once as opposed to individual selection. We'll begin by brick meshing the bracket. We use the until target as well as the Smart Selector to get tangent faces to select all 9 source faces. We'll use the same tangent face Smart Selector to select all 9 target faces as well. Go ahead and select the source mesh element size and we'll select OK. And here you can see we have a brick mesh on our bracket. Now the bracket has an additional component which we'll include for our next step. We'd like to create a mid-surface of it, so we'll unite the gusset into the main bracket before mid-surfacing. So now when we mid-surface the bracket, the gusset will be trimmed and extended into the main bracket. We'll go ahead and remove our brick mesh as well as the solid representation of the bracket and go into the merge edge command. So here you can see the vertices, various points that are available for merging. Now we can box select to remove them. We have some new capabilities with 2D meshing in the 2D mesh dialog for element quality. Here you can see we have some new capabilities for selecting limits for skew and target maximum element length. We also have extended the curvature settings such that the 100% minimum size setting is now 1/100th of the target element size, so that you can get high curvature variation for the areas where there is high curvature in your geometry. And this is extended as well into the 3D mesher. We have a new method for creating a point-to-edge connection, which allows you to rapidly create spiders at your holes. We have a new arc method, arc to centers. First we'll put a 2D mesh on our mid-surface, and here you can see the additional mesh quality options that have been added in Simcenter 12 for target maximum element edge length as well as skew. Alright, next we'll go into the 1D connection command, and we'll see when point to edge is selected, there's a new connection method for arcs to centers. Here we can select our favorite 1D element type, select the arcs we would like to create the point to arc command, and here you can see it's created our spiders. We've improved the internal mesh size control in the 3D mesher, such that you can adjust the gradation of the mesh to grow as it goes from the surface to the interior. You can select an internal mesh gradation, which selects the multiplier from the edge lengths as the mesh goes inward, so that we can better see what's going on inside the mesh. We have some improvements in the clip section display of element intersections. This provides a cleaner view of the internal elements when clipping a section and showing the cap. First, we'll put a tet mesh on our part. Give it an element size, and we'll make sure that the internal mesh gradation is set to 1. And then we'll go ahead and take our section cut through to see what's going on inside the bracket. And here you can see the nice element edge intersection display, so we can see what's going on. We'll go ahead and split it somewhere about halfway through, and then we'll edit our tet mesh to increase the mesh gradation. So we'll put a factor of 2, so we'll multiply the element edge length by 2 as it moves in for each element from the outside towards the interior, controlling the growth rate. And there you can see how the elements are much larger on the interior, but have remained the same on the exterior. Simcenter 12 is the introductory release for universal connections. This gives us the ability to take CAD parts, assemblies, and finite element meshes and create a unified assembly, which supports batch meshing and defining your connectivity data, then allows you to write out your finite element model in any of the supported environments. So this is sort of like a solver non-immersive environment where you can define generic connections such as spot weld, adhesive, rigid, and the universal connections will then interpret that connection into the specific environment that you'd like to write it out in. So here for universal spot welds for Nastran, you can see that it will write C-hexa plus RBE3s or RBE2s or C-bars and RBE2s. And this is dependent upon the type of elements that you're connecting to as well. So here you can see the different types of universal connections that are created. We also have some new capabilities in Simcenter 12 for selection recipes, and this captures the selection intent for CAE. Here you can define a selection rule, and this can be based on attributes, bounding volumes, node or element label ranges, and then this can be then used in the creation of a load or a constraint. So here we can see the attribute selection, and we'll take a closer look at this in the demonstration in just a moment. But you can assign an attribute to a edge or face and in the CAD, and then bring that into the FEM to define your selection recipe. Similarly, we can use bounding volumes or label ranges for selection recipes and points or coordinates. Demonstrate selection recipes, we'll begin with applying some attributes to some faces in the CAD model. Here we'll select a couple of the whole faces and we'll add a name. If we'd like, we can also turn on the name display in our visualization preferences. So there we can see the attributes that we've applied to those faces. Next we'll go back to our finite element model, and here we'll create our selection recipe. Here you can see in the Simulation Navigator there's a folder for selection recipes. There's a number of different types of selection recipes we can create. We'd like to use the attribute selection recipe, so we can leverage our fixed attribute name that we put on those holes. We're going to apply it from the polygon faces that the names were applied to, and that was the name fix that we put on it. Here we can see that we'd like to resolve that to the related nodes. Now we can use that selection recipe in creating a constraint. So here we'll create a fixed translation constraint. Now for the object that we'd like to select, we need to make sure the selection bar is on selection recipe. And then we need to select the selection recipe out of the navigator. So here we'll expand our folder with selection recipes, and you can see now that the fixed translation constraint has an object selected in it, and we can apply our fixed translation constraint. Now this selection recipe will survive a CAD update as well. So here let's go back to our master CAD part. We'll go ahead and select a few additional faces that we'd like to apply that same name attribute to. And then let's also make a change to the size of these holes. We'll use the synchronous command to do that. We'll also look for equal radius holes, since all four are the same, and we'll change all four at the same time. Now we'll go back to our finite element model. You can see there's a mesh update waiting. We'll go ahead and update the mesh. Our selection recipe also has updated. As has our constraint. We have new manual meshing capabilities to define an element extrusion in the radial direction as opposed to linear direction. We have a new move node user interface where we have now upgraded it for the standard dialog user interface. We have new mesh controls. First we'll take a look at is the size on a point. Here you can define your element size at a point as opposed to an edge or a face. We can also control the mesh in terms of the size on the bounded volume. So here we can define a volume which needs to be interior to the solid body and an element size, and that will then control the element size inside the volume. We also have the ability to put a mesh control at a point inside the volume as opposed to just a volume definition for a mesh control. And you can also assign a node label to a mesh point when you create one now. to drive a specific node label, to always survive CAD updates and always have that label. First, to create a mesh control on a point, we need a point to apply the mesh control to. So in our finite element model, we'll begin by creating a mesh point. And here you can see the assign node label option as well. And we'll select that point somewhere in the middle of our face. Here we don't want to assign a label, so we'll keep that off. And then we'll go to the mesh control and define our size on that mesh control. Here we can select an element size and also a radius of influence. And that will control how far from that point the mesh control will be applied. So there we can see our finer mesh, the center of that surface going out to its radius of influence. We'll assign a mesh control size on volume. We already have a volume defined inside the part, which we can see here if we turn on the additional polygon body. And we'll use that in defining our selection recipe. This needs to be completed first before we can define our size in volume, mesh control. So we'll select bounding volume. We'll do a box 2 diagonal points option to define the volume. We'll select all of the entity types that we want to include, and that defines the selection recipe, which now we'll use to define our mesh control. So here our bounding volume mesh control we'll select our selection recipe as we had before out of the navigator. We'll select the body that we want to apply that mesh control to and the element size that we'd like inside that bounding volume. Now, before we do the mesh update, let's go ahead and take a look at what the mesh looks like currently in that location using our clip section. And you can see it's relatively coarse through the volume. We'll go ahead and leave it somewhere halfway down and update our mesh. And you'll see that the mesh now has a mesh control only in that location inside the volume. Go ahead and change our clip section, and you can see as we go outside of that volume, the mesh control no longer has influence on the mesh. We have some new 2D mesh checks in regard to the 2D element area. We can check to make sure that the 2D element area is greater than or equal to a specified size. We can also display and align 2D element at first edges. And this is helpful when creating a 2D mesh that will be used for a laminate definition. We also have some new sorting and filtering capabilities on the mesh collectors so that you can sort by name, which can be helpful if you have a great deal of mesh collectors and need to navigate through them. Next, we'll take a look at post-processing capabilities. We have quite a few new post-processing capabilities. We'll take a look at a few of them here. You can see the others at the What's New guide. First, we have on the ribbon some new capabilities. We have slimmed down dialogues compared to the old edit post views so that you can directly get to specific commands such as turning on and off the deformations, what type of contour plots you'd like to look at. So we still do have the old edit post view, but it's been reorganized as well to improve the workflow. And in some areas, such as set results, nothing has been changed. But I think you'll see that it's greatly improved. We have a new quick edit command group on the ribbon, which also helps to rapidly adjust your post-processing view to be exactly what you'd like. We also have a new some additions to the tools group, which we'll take a look at in the demonstration as well. And we also have the ability to resize viewports. You no longer need to have, let's say for a 4-view view, you no longer need to have all 4 views the same size. You can bias the views' sizes and save that with a layout. Let's go into post-processing and open up a result. So here we have a deformed shape, and here you can see some of the new options in the quick edit ribbon. We can easily change from a smooth to a banded to an ISO line. ISO surface doesn't apply since it's only a 2D mesh. We also can turn on or off external edges, and we can also change the deformation. All right, next what we'd like to do is edit the legend. Here we can select the new Edit in Graphics in order to control exactly where we'd like to put that legend, as well as by right-clicking we can scale it up or down in terms of its size. Next, to demonstrate the resize viewport, let's go ahead and get a multi-view layout and a couple of different results visible as well. Then we'll go and resize our viewport. And if we'd like this viewport to be available later, we can save it as a layout state. So we'll say Save State, give it a name. And this layout state will reside in a folder off of the Simulation Navigator. Here you can see our layout states. So let's go back to the preprocessor with a single view. If we apply that layout state, you can see it brings us right back not only to the resized viewports, but also to the results that we were looking for. We also have new capabilities for post-processing nodal force reports. And this is to enhance the free body diagram capabilities that existed previously. We have the ability to specify the nodal force reports in the preprocessor and then be able to plot them very quickly and easily without having to go to post-processing and define a free body each time. To create the nodal force report, we'll go ahead, right-click on the solution, and we need to make sure first that we have grid point force output selected and available in our results. Then we can go ahead and create our nodal force report, also by right-clicking on the solution. Here we can select the type of force that we'd like. Go ahead and give the nodal force report a name as well. Then we'll go ahead and select the elements that we'd like to include in the nodal force report. Go ahead and select a couple of rows of elements here. And then we'll also select some nodes. Now this definition is going to survive with the nodal force report. Here we don't want to add the forces or calculate moments at this point, but we would like to create a post view of the output on the fly, and here you can see all of our grid point forces. Now here you can see we have a nodal force report folder in which we can then reinstate that nodal force report. We can create a table field or even a new solution based on that nodal force report. If we'd like, we can create another nodal force report. This time we'll add all of the forces and moments. Go ahead and select the same two rows of elements. And the same row of nodes. We have the option to calculate moments on the deformed coordinates or not. Here we'll also select a reference point about which to calculate the moments and sum the forces. And here you can see our results. We have a new Simcenter results viewer, which is a standalone post-processor. It has all of the capabilities on the post-processing navigator and the XY navigator. It's something that you can purchase standalone, so no other prerequisites are required, and it was first introduced in point release of 11.01. The Simcenter results viewer is opened standalone, and when you go to the file open, you only have results files that you can open. So we'll select Nastran results file, but you do have the XY function navigator and all the tools available within it, as well as all of the tools in the post-processing navigator. So here we'll go ahead and display some results. We'll create a multi-view layout and select a few different types of results. Resize the viewport. Now when we go to exit, it will ask us if we'd like to save the session file, which will save the layout state, which we can reinstate. So here we'll go ahead and give it a name. Then restart the Simcenter results viewer, open up our results that we were just looking at. From the Nastran OP2 file. Alright, and then to bring up our old results, we'll go ahead and right click on the session and apply from file. And then we'll go ahead and point to that file that we had just saved. And it brings up our results exactly as we had saved it from our previous session. We also have some continuous improvements in many areas. Here we'll take a look at just a few of these. First is we have the ability now to put annotations in the preprocessor. This is helpful for report writing. Here we have a new annotation manager, which allows you to adjust the display status You can organize them in folders as well. We also have a new solid properties check, which will give you the center of gravity about a reference coordinate system. We always had the ability to put out center of gravity at the global CSIS, but in some cases it's handy to have it about the work coordinate system or some other saved coordinate system. We also have some new capabilities for doing force breakout modeling, where we can save force and moment loads as spatial tables, which can then be applied to your breakout model. And that concludes the demonstration.